What's up, tubular YouTubers? It's video 10 on variance, sample variance, and standard error of the mean. Shall we get started? I think yes. All right. First, let's talk about variance. This is the variance formula. You should go ahead and get that down. Like standard deviation, it measures how far a set of random numbers are spread out from their average value. And it's a little bit different than standard deviation for the formula, but not much at all. Let's go ahead and let's compare the two. What do you notice? You notice the variance doesn't have a square root. Well, how would we get from standard deviation to variance? It's just the square, right? If I were to square this, it would undo the square root, and we would be left with just this. So what I'm trying to say is don't panic. The variance is just the square of the standard deviation. That's it. Let's talk about units for variance. Now, standard deviation, you might get something like, for vertical leap, there's a 5-inch standard deviation. Well, the variance is the square of that. So what's 5 squared? It's 25. And what's inches times inches? That's inches squared. So variance would be 25 square inches. What if I said 7 feet for standard deviation? Then our variance is 49 square feet. What if I said maybe 6 points for standard deviation? Then our variance would be 36 square points. Now, that doesn't really make sense, points squared, and that's why, I prefer standard deviation, but there is a reason for variance. Why do we care about variance? Well, because variance shows up in various formulas. Remember that this symbol right here stood for the population standard deviation. So this would stand for the population variance. Okay, and look at where it is. We've got all sorts of things showing up here with our variance popping up there. And now, what does this talk about? And I don't know too much about this formula, but what I do know is that it measures risk, and the fact that variance is in the formula is fairly interesting. So I think on a kind of a verbal day-to-day basis that standard deviation makes a lot more sense, but yeah, variance is very relevant when it comes to certain measurements like risk. All right, so let's do a particular problem. Let's find the variance of the following data. This is the number of Facebook friends. Let's say that, I don't know, Abe has 400 friends, Rowan has 76, wah, wah. Now we're going to have someone with 84, 250, 725 for Miss Sorensen, and then Cello's 321. He's got 1,205. Okay. Now, I highly recommend going back and watching that video on finding standard deviation on your graphing calculator. And what you'd find, go ahead and pause the video if you want to find it, you'll find that the standard deviation is equal to 438.569, and that's going to be friends. And again, notice that I use the S on my graphing calculator for sample, because as much as we think we're the world, this is clearly not a whole population. So if that's our standard deviation, how would we get to variance? Well, we square the number. So this is going to give us a variance, 438 times 438. I'm going to include the decimals, and I get 192,342.768 friends. What's my units? Friends squared. Again, boy, that doesn't make much sense, squaring friends, but it is important for various formulas. We're going to move on to finding the variance of the sample distribution. Okay, what do you think is true about the variance for this sample distribution versus this one? Well, clearly the variance here is going to be smaller than the variance here. Here it's going to be bigger. You can see that this data here is spread out more than this data here. And, I just want to emphasize that the sample variance formula is just the sample variance for the population divided by your sample size. And that makes sense, right? I just told you here, if my sample size is 25, right, if I divide by 25, then I take my population variance, divide by 25, that's going to give me a smaller number than if I were to divide by just plain old 5. Like in this case, we've got n equals 5. So that makes a lot of sense. Here's a particular example. Consider a population with a mean of 30,000 in debt from a college credit borrows and a standard deviation of 500. For a sample size of 100, find the expected sample variance when considering the sample distribution. Well, there's something here that's not relevant. If we look, we need population variance and sample size. We don't care about their credit card debt or their college credit debt. What we do care about is getting population variance, but unfortunately, they only give us standard deviation. Well, we can simply calculate variance from standard deviation. We know if our standard deviation is 500, we square that number, and our variance is going to be 25. And then I'm going to have 4 zeros, 1, 2, 3, 4, because I'm doing 5 squared is 25. 2 zeros becomes 4 zeros. Okay. So now I have my variance, which is good. Do I have my sample size? Yes, I do. Sample size of 100. Okay, that's coming from right here. So I know that my sample size, or n if you will, is going to be 100. So our sample variance, I'll call it SV, is going to be equal to 25 with 4 zeros divided by 100. Let's go ahead and cross out 2 of our zeros. And we're left with a sample variance of 2500, 2,500. Now, keep in mind, standard deviation was in dollars, so this is going to be in dollars squared. All right, moving on. Sample variance, same problem here, really. However, notice that we are actually just flat out given the variance, so it's a little bit less work this time. So all I have to do is plug in to this formula. I'm given 1,000, and I'm given my sample size of 100. Actually, I don't really care about this. And I'm going to do that division, cancel out my zeros, and I'm simply left with 10. Again, we're talking about dollars. And since this is variance, this is dollars squared. All right. Now, this is such a terrible name for what we're about to do. It's called the standard error of the mean. I really don't like it. Why didn't they just say find the standard deviation of the sample distribution? That's all it means. Okay, it's all about the standard deviation, but they're calling it the standard error of the mean. So if you go back to these problems right here, if I say, hey, find the standard error of the mean, it basically means what's the standard deviation. Now, I guess I kind of get the name. It basically means like, hey, what's the spread? Meaning how far are the averages that people are coming up with away from the actual population average. So how far away are the means that people are getting? What are the errors of their means? I get it. But really, I'm just saying find the standard deviation of these blue sample distributions. Well, what is that? Here's your formula. All right, there it is right there. And you'll notice it's really the same thing except you've got a square root in the denominator. Okay, keep in mind your sample variance is the population variance divided by sample size. We'll talk a little bit more about where this square root came from. All right, let's do an example problem before I talk about that square root. Consider a population with a mean of 2 fishing rods and a standard deviation of 1. For a sample size of 16, find the expected standard error of the mean when considering the sample distribution. I'm basically saying find the standard deviation. So I'm going to use this formula right here. What's my standard deviation? 1 divided by my sample size, or the square root of my sample size. So that's going to be 1 divided by the square root of 16. That's 1/4. All right, and that's going to be equal to 0.25. Now we're talking about standard deviation, so our units are going to be just plain old fishing rods. Which really means that we were pretty darn close in our sample distribution to getting really close to what the actual average was. All right. Now, I do want to make reference to where this square root came from. And if you think about this, instead of writing population variance right here, what is population variance? Well, it's actually standard deviation squared. Okay? So if I wanted to convert this, I would square root both sides. So I would say that sample variance, okay, if I square root variance, I have to square root this whole side too. What's the square root of standard deviation squared? Oh, the squared and the square root disappear, and I'm just left with standard deviation. And what's the square root of sample size? Oh, that's where that square root came from. Okay, and what is the square root of variance? Oh, that's just standard deviation, or the standard error of the mean. So that's where the formula comes from. So one last review here before we are done. And the question is, the standard error of the mean is the blank of the blank. Okay, this is what I said was a silly name, but the standard error of the mean is the standard deviation of the sample distribution. The sample variance is the variance of the sample distribution. Okay, last question. This is asking for the expected mean, the mean of the sample distribution. The population mean for hours of television watched per week is 11, with a standard deviation of 2 hours. Oliver and others decides to survey 10 people to see if this is true. What's the expected mean for the sample distribution? This question is asking, what's the mean of these blue things? Well, it's the same thing as the population average, or mean. So here it says the mean is actually 11 hours. So what's our expected mean for the sample distribution? It is 11 hours. It is the same thing. All right, thanks YouTubers. Thanks for watching. Hit subscribe. Give me a like because I deserve likes. Thanks so much, and we'll chat again soon.